This video looks at acidic and basic salts. By the end of this video, you should be able to recognize acidic, basic, and neutral ions in a salt, and you should be able to write an equation showing why the ion or ions in that salt will produce an acidic or basic solution. First, recall that the term salt refers to any ionic compound, not just NaCl. We find that when salts dissolve, they may form a solution that is neutral, acidic, or basic. Neutral salts are salts where both ions, once dissociated, will not combine with H+, and therefore will have no effect on pH because the H+ concentration will remain unchanged. These salts consist of the cations of strong bases paired with the anions of strong acids. For example, when you pair any of the cations listed in this table with any of the anions listed in this table, you will get a neutral salt. Notice that each of the cations listed is the cation of a strong base. For example, group 1 ions such as Na+, Na+ is the cation of NaOH. Mg2+ is the cation of MgOH2, and so on and so forth. Likewise, all of the anions listed are anions of strong acids. Cl- is the anion in HCl, Br- is the anion in HBr, and so on and so forth. So why is this the case? Let's consider the acid HCl, which contains the anion Cl-. When HCl is placed in water, a reaction occurs in which the H2O is able to take an H+ from the HCl. This yields H3O+ and Cl-. Since this is a strong acid, this reaction essentially only goes in the forward direction. Therefore, the resulting Cl- ions are unable to react with the remaining H2O to form HCl and OH-. This reaction does not occur. Therefore, there is no additional OH- or H+ added to the solution, and the pH remains the same. However, if a salt contains a basic ion, it will produce a basic solution. Basic ions are anions that are conjugate bases of a weak acid. Recall that the weaker the acid is, the stronger its conjugate base. Therefore, these resulting anions are relatively strong conjugate bases and are able to react with water to produce OH- ions. Consider the following example. HF is a weak acid which reacts with water to form H3O+ and F-. F- is the conjugate base. Because HF is a weak acid, F- is relatively strong. Since F- is a relatively strong base, it's able to react with the remaining H2O, pulling an H+ off of this H2O to form HF and OH-. This increase in OH- concentration will cause the solution to be basic. Here's a list of some common basic ions. Notice that each of these ions is the conjugate base of a weak acid. Likewise, any salt that contains any of these ions will produce a slightly basic solution. Turning now to acidic ions, any salt that contains an acidic ion will form an acidic solution. Acidic ions are anions that are conjugate acids of a weak base. Again, as the base becomes weaker, the conjugate acid becomes stronger, making the conjugate acid able to react with water to form H3O+. Consider the case of ammonia, a weak base. Ammonia reacts with water to form NH4+ and OH-. This resulting NH4+ is a relatively strong acid. That NH4+ then reacts with H2O to form H3O+ and NH3. The resulting increase in H3O+ concentration will result in a decrease in the pH and a more acidic solution. Here are some common acidic ions. Again, notice that many of these are the conjugate acids of weak bases, such as NH4+ and CH3NH3+. The others are metal ions with large charges. In a moment, we'll look at why these have acidic properties. Any salt that contains any of these ions will dissociate in water to produce a slightly acidic solution. Finally, let's look at the case of acidic metal ions. Generally, when a metal ion with a large charge, such as +3 in the case of iron here, dissolves in water, it interacts with several water molecules to become hydrated. Here's our iron atom represented in orange in the middle, and our 6 water molecules, which have hydrated the iron ion or formed a complex around the iron ion. When these water molecules interact with the iron ions, it weakens the bonds between the hydrogen and the oxygen in the water molecules. This makes it easier for a free water molecule to take an H+ from one of these complexed water molecules. Here we see that the hydrogen that was part of this water molecule here has been taken by a free water molecule to form H3O+. Again, this additional H3O+ will result in a slightly acidic solution and a decrease in pH. Here's some examples to consider. Pause the video here, and when you come back, I'll reveal the answers. Welcome back. Here's what you should have gotten. Notice that calcium chloride is a neutral salt because calcium is the cation of calcium hydroxide, a strong base, and chloride is the anion of hydrochloric acid, a strong acid. Each of the other salts, however, contains an ion that has acidic or basic properties. The equations showing those ions reacting with water are shown here. That brings us to the end of this video. Let's review our goals. First, we learned to recognize acidic, basic, and neutral ions in a salt, and then we looked at equations showing why the ions in that salt will produce an acidic or basic solution.